Okay, we have a question. Evaluate limit x tending to 0, root of x plus 1 minus 1, the whole divided by x. Step 1. Let us apply the limits. Okay. APL stands for applying the limits. Okay. So when I apply limits, that is to say, wherever I see x, I substitute 0. So this would give me root of 0 plus 1 negative 1 divided by 0. Root of 0 plus 1 gives me root 1 minus 1 divided by 0. Root of 1 is going to be 1 negative 1 divided by 0, which would give us 0 over 0 form. Okay, so this should be step 1. Okay, now step 2. Okay, I'm going to use the principle of rationalization. I'm going to use the principle of rationalization to evaluate the limit. Okay, so how am I going to do that? What I'm going to do now is I'm going to multiply the numerator and the denominator by the conjugate of root of x plus 1 minus 1. So this is going to be x plus 1. So its conjugate is going to be root of x plus 1 plus 1, and I'm going to divide by the same conjugate, root of x plus 1 plus 1. Okay, now there is a formula which says that a minus b times a plus b equals a squared negative b squared. So I'm going to apply this formula, and I'm going to show something in the working column. Okay, working column. So what I'm going to show in this working column is root of x plus 1 minus 1 times root of x plus 1 plus 1 is very similar to a minus b times a plus b. So a minus b, a plus b is going to be a squared negative b squared. Okay, so similarly, in place of a I have root of x plus 1, and in place of b I have 1. So this could be written as root of x plus 1, okay, in place of a. So that means I need to place a square here, minus, in place of b I have 1, so that's going to be 1 squared. So the square and the square root gets cancelled, giving me x plus 1 negative 1 square is going to be 1 square 1. Since the sign is negative, I am retaining the negative sign. So plus 1 and minus 1 gets cancelled, giving me x. Okay, so this is the working that I am going to apply. Okay, so since I've already shown you the evaluation, I can simply place the value of x in the numerator. So this is going to be x times root of x plus 1 plus 1. So it's going to be root of x plus 1 plus 1. Okay, now x and x gets cancelled, giving me 1 over root of x plus 1 plus 1. Okay, so therefore limit x tending to 0 of 1 over root of x plus 1 plus 1. In place of x I substitute 0, so this would mean I have 1 over root of 0 plus 1 plus 1. Now this is nothing but 0 plus 1 is going to be 1. Root of 1 is 1, so 1 plus 1 gives me 2. So that is maybe I'll write down what I just told. So this is going to be root of 1 plus 1, which is 1 over root of 1 is 1 plus 1, which is 1 over 2, which is the solution.